As you can see here, I have got two exponential functions and I've defined them on the graph page, and I've got the graphs up. I've changed my window settings so that I can see all the important points. I've already showed you how you can use your graph page with Analyze Graph and Trace to find those points, but sometimes you want more accuracy than 1 or 2 decimal places, and to do that you need to use your calculator page. You can open a calculator page by going to Menu and hitting this first one here, which is your calculator page. Right, so if I go back to the document and I've got my calculator page already opened, I can now figure out different values. For example, if I want function number 1, you'll notice it goes bold because that function is already defined. I defined it in the graph page. And if I wanted to figure out where the y-intercept was, I'd have to let x equal 0. So instead of typing function 1x, I changed the x to 0. And it tells me that the y-intercept was 47. If I go back to my original page, there's my function 1. I'm looking at that point there. I just check, Menu, Trace, Graph Trace. I want the other function, so I hit my up arrow, and now I'm going to move that across until it gets to my y-intercept. Yep, 47 is what we had for the y-intercept on the graph page as well. If I wanted to figure out x-intercept, then the way to do that is I go to Menu, Algebra and Solve, and I want to know what is the x value when the y value is 0. So the y value equals 0. That's the function number 1. And I want to solve it for x, so I put a comma x. So to figure out the x-intercept, that's what I type in. When does the function number 1 have a value of 0? Tell me what x value makes that true. And it tells me negative 61.09. I'll go back to my graph page. Again, I can use my graph trace and I can just type in negative 61, but I won't. I'll go around until it says 0. There it was, 0, negative 61.1. Okay, so you'll notice negative 61.1 is what I get on the graph page, but I get more decimal places on the calculator page. If I want to figure out where they intersect, then again I can use my solve command. This time, rather than typing it again or using my menu, I'll just hit the up arrow a couple of times. I'll copy that and I'll change it. I want to know where the function 2 has got the same value as function 1. So if I press enter, it'll now tell me what the x value of where those two meet. If I wanted to figure out what the y value was, what the function's value was at that point, then I can just simply say function number 1, then I hit my up arrow. You'll notice it not only gives me the 4 decimal places, it gives me even more. And I press enter. So it tells me it is at 113.137. If I did function 2, I should get exactly the same answer. And I do, 113.137. One more last thing to note is that these two functions look a little bit different to the functions that I typed in. Functions that I typed in were 60 times 5 to the power of 0.02, and the other one was 10 to the power of 0.02. Down here for my black graph. They look a bit different on this page. The reason is that the calculator has taken a shortcut. 10 to the power of 0.02 was equal to that one there. So it's just kind of simplified the equation a bit, but it is still the same equation. So, summary of what you can do is, if you want to find the x-intercept for a graph, say function number 1, we want to let that function equal 0, we hit solve for the function equals 0, and it tells us the x-coordinate. If we want to find the y-intercept, that's where we want to let the x value be 0. So we simply type function number 1 and replace the x with the value we're interested in, 0. If we want to find intersection points, we let the two graphs equal one another. And if we want to find any other value, for example, when does the function reach a value of 100, I can just type in solve function x equals 100. If I wanted to figure out what is the value of function 2 when x was equal to, say, 1, I just type in 1 in place of x, and it'll tell me what the function's value is for an x value of 1. So this is when we want to find an x value for a y value. This is when we want to find a y value for a given x value.